Welcome to Workflows4s DevLog, episode 1. Before we start, let me explain a little bit what we are doing here. So, for some time now, I've been working on this project, Workflows4s, and I would like it to be as friendly to newcomers as possible, especially early developers, early contributors, because the project is still a kind of proof of concept quality. And I thought maybe I can share my PRs through videos. So we'll sit and talk about what happened in some recent development. Normally this would not be required because pull requests are small, self-contained, and easy to understand. The problem with my work, kind of in general, is that I rarely know what I'm doing. So I only know where I'm going at the very end of the process. So to make a PR friendly, I would have to do it basically from scratch. So instead I thought, okay, let's leverage the thing I'm doing at work. So if the PR is too big, then let's do a walkthrough. Great. So today we're going to focus on progress tracking. And you might not know what this means. So let me show you first. So we have a workflow that can be visualized. Let me pick an interesting one. So unfortunately, the Mermaid plugin for IntelliJ broke in current EAP. So let's see. We have to use the online editor. So this is our workflow, more or less. So we are modeling a funds withdrawal. We create it, validate, calculate the fees, log the funds, check if everything is okay, and then execute it, meaning send it to a counterparty, and then release the funds. This means just take the funds. That's heavily inspired by my work at Swissborg, as you may imagine. Okay, and now we want to know what happened to a workflow that was running. So this means, in the end, we might want to have something like that. So we see that the workflow got created, validated, the fees were calculated, the funds were put on hold, but then it was cancelled and the funds were brought back to the user, and that's it. Okay, the visualization is not perfect. Like maybe the arrows should be green as well, or some visually distinct. That's not the point. The point is we want to have that information to be able to render this form or any other. Okay, so how this happened? That's a good question. And to know that, we have to start a little bit from scratch. So Workflows4s is based on the more or less single ADT, which is called WIO, that has some input, error channel, output that is bounded by the state of the workflow. This doesn't really matter. The variants are like, you can handle signal, you can run IO, you can flat map, but that's, the better one is end then, so you execute 2 steps in succession. So that's just a data structure. You interact with that data structure through something called workflow instance, which is much simpler. So today we will not discuss how you get the instance, but assuming you have it, you have those operations available. So you can query the state of the workflow. You can deliver a signal. You can wake up the workflow, and you can get the current progress. This is a new operation. It was not available before. Now, if you look into the implementation of the instance, and there is quite a few of them, because every runtime gets a dedicated implementation, we'll see how this works. So this is the implementation is an intermediary layer between the interface and something that is called active workflow. The naming is hard, sorry, the name is terrible. It will probably change. But this is a generic implementation of the logic. And here we can see what happens when you, let's say, handle a signal. So when you handle a signal, you might, assuming there is a appropriate handler at that point, you might get an IO of an event and a response to the signal. Okay, so it's a factual operation that produces an event and a response. What happens when you wake up, like if we go back and look at the wake up, then you will also see this includes this calls the proceed operation. Once again, naming is hard. It's not very consistent. It doesn't really matter here. The point is, when you move workflow forward, you might get an IO of an event. And then on those, then you have to separately handle the event that, based on this, can give you a new workflow. Okay, so there is no state here. It's just a wrapper with some behavior that handles those operations and might eventually give you a new instance. So now we need to make another small detour and understand what happens when we handle event, how we move the workflow forward. And as you can see, there is something called event evaluator. Now, if you look into the repository for this class, we can see that there is a whole bunch of evaluators, different evaluators. The name, once again, is not great, doesn't really matter. The point is, those classes, those objects, basically encode the traversals of the tree, of the AST, you could call it. So it goes through our instance of WIO and tries to apply the current event. So now maybe it's worth looking at what was happening before the changes we did for progress tracking. So if we look at the diff on the event handler, okay, the diff might not be very convenient, but let me find one thing. So let's look at and then. And okay, it's not here. Okay, it should be here. Oh, here. For some reason, it's case sensitive. Good. Yeah, this view is crap. So sorry. Let's start again. Let's look at what happened to the event evaluator on the current main branch. So when you go to here and look for and even and then, which is one particular operation that once again combines two executions. So you have one WIO that takes an input, produces out one, and then you have the second that consumes out one and produces out two. Very simple sequencing of operations. So what happens here is that when we try to process this element, we apply the event to the first step and optionally preserve and then. So now this gets a little bit complicated because what is the return of this function? So it's something called new workflow state. This is an internal thingy, and that name is terrible. It got renamed in the pull request as well. But you can think of it as a new behavior. Like we try to return a new WIO to be used in the new workflow. So now what happens is that we do this. This goes to, let's say, an event handler, the signal handler. On signal, we say that we handle the event here, and then we return this new value thingy. So the output of the handle is just the output value of the new state of the workflow. Okay, when I say new state, I mean the type parameter here. So the actual state of the workflow, like visible from outside. But okay, now we did that, but we were coming from end to end, right? So this was the first operation. So what should be the new behavior of the workflow? If we look here, and you see in this very cryptic message that if we received a new value, which we did, you go and your new behavior becomes a WIO second. So basically what happened here is that we had, and then we applied event to it. The event got consumed, you produced the new state, and then the new active workflow is the new state plus the second WIO as a new behavior. Okay, this might not be super clear, but hopefully it's enough for now. Now let's go back, or not yet. So with that model, I tried really hard to put the progress tracking on top. So how could you do that? One idea I had is when we go through event, we are in this event handler, event evaluator, sorry. And so we could return alongside the new behavior and the new state, we could also return what was consumed, what was evaluated. So in that case, in our example, this would be this handle signal object. Okay, so we know this was evaluated. Maybe we can somehow figure out where it was in the large picture, like on the whole workflow as a whole that we know is the beginning. Then we need to figure out where it is, or in more graphical terms, like we get this single block, but now we have to find it in the flow. And this turned out to be quite complicated. Another idea I had was to give IDs to those structures. And I even exercised this idea. I tried to do this. And this turned out to be neither helpful nor convenient to work with. You can assign IDs based on the, I think it's called topological structure or something like that. Basically a sequence of, in my case, it was a sequence of ints. So the first child gets 1, the second 2, and then you go down and build the ID as a sequence. But this didn't work. So now we can take a look and see what happened in the final implementation. So now if we look at the same thing, we look for the and then step, which once again cannot be found for some reason. Okay. So now what happens is that when the thing is executed, maybe we can start with the handle signal. Even evaluator signal. So now when we handle the event, we build something called workflow execution complete. And this is just a helper function that creates this workflow execution complete. But if you look at the signature, it contains a new thingy, WIO executed. So this is an element of our ADT that contains the original workflow that was executed and the output it provided. It also captures the input that was passed to it. I'm not 100% sure it's strictly necessary. It was necessary, but to implement what I needed, but it might be a bit accidental. So yeah, we produce WIO executed, and WIO executed is a new behavior that will be ignored by all the evaluators, or like semi-ignored. It doesn't behave in any way. It doesn't act, but it is embedded, let's say, in the overall workflow. So now if you look at how the and then is handled, so we first check if the first item is executed. If so, we recurse on the second. So we never eliminate parts of the workflow, we just replace them. And if the first was not executed, that's maybe the interesting case. Like we recurse on the first, and then we say that we have a new partial execution, meaning it's not complete, it hasn't finished, it has a new behavior, which is, the new behavior is, and then the resulting wheel, because the result of a recursion was also the workflow execution, and the second. So here, in practice, we'll have VO executed something. So now you probably understand how this works. On the next iteration, you go here, you see that this was executed, and then you can recurse on the second element. So I believe this model is pretty elegant, and maybe to show you something more to make it more tangible. How do we extract the current state of the workflow? Because once again, if we go to workflow instance, we have this query state thingy. Now, if we look at the some implementation, we'll see that there's we want to have a live state of this thingy, and ignoring some of the complexity along the way, in the end we reach the static state and get state evaluator. Okay, so one more evaluator that traverses the data structure and tries to extract the state of the workflow. Okay, how does it do it? Let's say we had a and then, right? Once again, the same variant. And so if we check if the first element was executed, and if it was, and it was not an error, we recurse on the second, trying to extract even newer state from the second. And if we don't find it, because this is the option here, here, if we don't find it, we just take the state of the first element. Okay. The interesting thing is on top. So when we actually have when we actually get the state is when we hit a VO executed. From there, we take the output, which is inside this data structure, and just take the state, because it might be an error, it might be a state. Doesn't matter. Cool. So this is how it works. Maybe we can go back a little bit to the where proceeding evaluator here, and then proceeding visitor. Here, one more thing I want to show you is that what happens when we process the second item. So when we processed the second and it returned a complete execution, this means the whole second was executed. Okay, and this means both the first was executed and the second was executed. So then we wrap the whole thing. So we return also wrapped executed, like the and then consisting of both executed nodes. And this allows us to optimize this event, the get state evaluator, because we will not traverse the whole graph. We'll just stop as soon as the node is executed. Cool. That's the gist of it. Now, what it means in practice. In practice, it means that we want to consume this information somehow, right? We want to either render the new diagram that shows which steps were executed, or we want to do something else. And to do that, we have another IDT, which is like WebUI execution progress that you can get out of the workflow instance, that builds a simplified static representation of the model. So, for example, you can see we have now a sequence that has a sequence of steps, each of which is execution progress. This is a flattened and then. So if you have and then, then this is all simplified for easier consumption. And even though this WebUI execution progress is a new thing, we had before, Workflows4s had before something called WebUI model that was used to render diagrams. So maybe once again, a small detour. If we open the Workflows4s documentation, and if you go to the workflow elements, running side effects, you will, or any other step here, you will have those things available. So this snippet produces either this piece of a diagram with mermaid, or this piece of a diagram with BPMN, or this model. So the model we had before is very similar, but now it had to be enhanced to capture also the execution progress. So the information if a given step was executed or not. And I spent quite some time trying to figure out what's the best way to do this, because turns out it's not trivial if you want to separate concerns, if you want to have one model for the non-executed thingy and the other for executed. I don't know yet if we actually need this historical one. Maybe we can use just WebUI execution progress. It will have no progress by default, but then it's equivalent to the model. So maybe it's redundant and this will get dropped. We'll see. So now if we look at this, let's say, yeah, all the instances of all the variants of WebUI execution progress, they have this execution result, which is the option either any or state. Why any? Because errors in Workflows4s don't leak out. They're internal to the workflow instance. They are always guaranteed to be handled, in the sense that they are business errors. So they modify the flow. When you hit an error, you just end up on a different path of the workflow. Hence, we can have them, but we don't expose the information about what they are outside of the workflow. Hence, when we capture it, they become any. It might change in the future. For now, we don't care much about the error channel here, but we still capture that information. So now, if you see that so now the result of a sequence is the result of the last step. Now the question is that correct? And now I'm not entirely sure. So maybe I need to verify that. But what else? The run IO, for example, that can be executed and thus produce a state, has the result baked in here. Same for handling signals, handling errors, pure executions. Loops are very interesting. I think there will be a dedicated episode on how to handle loops. But basically, that's it. That's the data structure. It has the result baked in. Now we can use it to render the diagram. So now, how is that done? What was there before is the mermaid renderer. We have, I think, two renderers. One is for One uses Mermaid, the other uses BPMN, Java API from Java model from Camunda. But only Mermaids currently supports showing the execution progress. And that's pretty simple, because when you render stuff, you have this small thingy saying if the current step is executed, use the executed class, and if not, then not. Okay. And if the nodes with executed class has the green filling that you have seen. Cool. We could talk about how the Mermaid renderer was built, because there is a semi-interesting bit here. It relies on the state monad. So for those who never use the state monad, this might be an interesting bit of knowledge, but maybe not today. There is one more thing I would like to talk about today, which is accidentally I developed something new, or almost new. And why accidentally? Because in scope of this thing, if you look at the change set of this progress tracking PR, it basically touches like the big chunk of the code base. I think more than half, and it obviously broke some stuff. Luckily, I had tests, but it's not exactly trivial to debug the problems, like when your workflow gets executed and it goes in the wrong path, okay, for some reason. But turns out that now I have tools to do something nicer. And I developed something called debug evaluator that just renders a string that shows you what is currently happening. And we'll not look into the implementation, because that one is pretty boring. What we can do instead is we can go to the tests, run them, and look the debugging in real time. So let's say we want to look on the happy path. So this is the interesting stuff. Maybe just one small change. No, this should be a bit more readable. And yeah, this and one more new behavior. Okay, now let's look at the happy path. So we have a sequence, and the first step, which is handling errors that then have a sequence inside. It has interruptible block and a sequence of steps inside. And the first step of it is to handle this signal, create withdrawal. So this is actually the step that we are in. The output could be improved, so this is more visually distinct, because this is the actual step that is like next in line. Then you have 8 more steps that from debugging perspective are not that important. Like you're interested in what happened before, not what will happen after. And then we see that we are handling the signal, create withdrawal. We have the event, we handle the event, and then we updated the workflow. And now we have the same prefix, let's say. We see that the 0 step was executed with that state, and now we are here to run IO, calculate the fees. Now we're running IO, we are saving the event, we are handling the event, we are updating the workflow. And what happens now is that, okay, this was executed before, this was executed right now, and we are in this state. And it continues like that through all the steps. It might get folded at some point, yes, because that sequence, when this gets executed, this also gets folded. So now we are here, like this step 0, interruptible. We see that it was executed, because if the last step finished, the whole sequence finished, and this means that interruptible block also finished. So we are now back here. And we see that this was our state, and now we are on the step release funds. Okay, so this is a side benefit of all of that. I could implement a pretty convenient debugging of the execution. Obviously, the format can be improved, but that's not the important part here. And another side issue is that having that logic allows us to have something even nicer, which is the WebUI. So this is the idea that I submitted for the Google Summer of Code this year. So hopefully there will be someone working on this. And the gist of the idea is that now we can just have a web page that shows you that rendered diagram. It can probably stream the state changes over a WebSocket, probably, from the service that runs the workflow into the UI, and then you have a nice thing to monitor your workflows. Also in production. Cool. Thanks a lot. If you found this video, you probably know where to find Workflows4s, where to find Business4s, where to find me. So if you have any questions, join the Discord, ask, shoot. I'm always happy to answer. And if you want to contribute, I'm very happy to have you. You can message me. I'm happy to give a onboarding session, find some new early issues. So thanks a lot.